Hello everyone. Today I'll be taking you through one of the rooms in my home and how to make it more comfortable. So the dimensions of the room is a length of 12.3 feet, a height of 8.6 feet, and a width of 8.083 feet. The initial conditions of the room. So the temperature when I took the picture of the psychrometer was about 54.4 degrees Fahrenheit and the humidity, relative humidity of 57%. Now, the ideal conditions given by the professor was 70 degrees Fahrenheit and 50% relative humidity. Now, according to my psychrometer, the temperature in this room is about 16 degrees less and about 7% more humid. Now, an interesting fact is when I took a picture of the psychrometer, the temperature outside was about 57 degrees. And I've noticed about this room is that when it's cold outside, it's cold in here. When it's hot outside, it's hot in here. So the insulation is pretty bad. So how much energy would be required to bring the conditions to the ideal ones? So we have two equations. The mass of the air, which is volume times the density times the air changes per hour, and the heat required, or the energy, is the mass of the air times the change in enthalpy. So first we find the volume of the room, which requires the equation for the volume of a cube, or a rectangle, sorry. And it would just be multiplying the length, width, and the height to get 863.1 feet cubed. Now, what is the mass of the air? Well, if referred to the equation above, we plug in the volume that we found earlier and the density of air in pounds per feet cubed, which I found from Google, which is about 0.0765 pounds per feet cubed, and the air changes per hour I found in a website called HVACR, which apparently the minimum is 6 per hour. So multiplying those, you get a mass of 396.2 pounds. Now, to get into enthalpies, we'd have to refer to the psychrometric chart. Now, the way to use the psychrometric chart is you take the temperature and you bring a vertical line all the way up to the relative humidity, and you follow the slope of these reddish, like maroonish lines all the way until you reach what's called the specific enthalpy scale. And where the intercept, according to the scale, is what you have for the enthalpy for that temperature. And you do the same for the temperature and humidity given by the psychrometer. And the difference between them, for me was 5.6 BTU per pound of air. Now, you multiply the mass of the air times the change in enthalpy, and you get a value in BTU per hour, or in BTU, but every hour, which was 2,218 for me. Now, I converted the BTU to kilowatt hours with the conversion rate of 1 kilowatt hour is 3,412 BTU. You get a value of 0.65 kilowatt hours every hour. Thank you.